Okay, we are given the function fr as this. Okay, I want to show that fr minus 1 can be re-expressed as a constant multiplied by r squared. Okay, so let's just work on the left hand side. Left hand side is fr minus 1. Okay, fr, it is of course 2r to the power of 3 plus 3r squared plus r plus 24. We minus away fr minus 1. Okay, it is so tedious here. So this is going to be 2 times of r minus 1 to the power of 3 plus 3r minus 1 square plus r minus 1 plus 24. Where I need to expand this, okay, before I can even simplify. Okay, so let's do it. Okay, so this is going to be equal to 2r cubed plus 3r square plus r plus 24 minus minus of 2, this expanding it using binomial expansion, it is going to be r to the power of 3 minus 3r squared plus 3r minus 1 plus 3 times of r squared minus 2r plus 1 plus r minus 1 plus 24 is plus 23. And if you were to simplify all this, you are going to get just a 6r squared. And this is what the question wants us to prove. And 6 here is definitely the a that the question has shown. So a is going to be equal to 6. With this result, I'm supposed to find a formula for summation of r squared from r is equal to 1 to n. So what I want is summation of r from 1 to n of r squared. In order for me to make use of the result that I have here, what I have is 6r squared is equal to fr minus fr minus 1. Okay, this tells me that r squared is 1 over 6 of fr minus fr minus 1. Well, I'm going to use this and substitute and replace r squared by 1 over 6 fr minus 1. So this will become summation of r is equal to 1 to n of 1 over 6 fr minus fr minus 1. Okay, so with this, 1 over 6 I can factorize out. I'm just going to evaluate this. And if we were to think about all the possible methods to evaluate summation, according to what we have discussed in our outline, there are 3 possible methods. One is to use the calculator. It is not possible for us to use a calculator for this. Second is to make use of standard form. Maybe it is possible, but since fr is expressed as r to the power 3, maybe it's not such a good idea. We do not have a standard result that is that can help us to deal with r to the power 3. So I guess it is left with that only method which I believe you would probably have guessed in the beginning, method of difference. Okay, so this is going to be 1 over 6, applying the method of difference, rewriting it according to the method of difference pattern. Okay, this is going to be f1 minus f0, then plus r equal to 2, so f2 minus f1 plus f3 minus f2. And how many rows should I write? We should always write enough rows so that I can see at least 2 actual cancellation, okay, or 2 repeated pattern of cancellation. So with 3 rows, I managed to see 2 repeated patterns of cancellation, and that's where I'm going to stop. Okay, then plus dot dot dot, and here I'm going to write another 2 rows because 2 rows is supposed to give me 1 set of cancellation. So if for that 2 rows, if I can see this same cancellation pattern, okay, that means that the cancellation pattern is going to propagate all the way until that very last 2 rows. Okay, so the second last row, it is when r is equal to n minus 1. So this is fn minus 1, fn minus 2. Then plus this is fn minus 1. Okay, so it is that same pattern, which means that in between here, all will be cancelled. So what I'm going to be left with is a 1 over 6 of fn minus f0. F function, it is that. So this is 1 over 6. Using that fn, I can re-express it as 2n cubed plus 3n squared plus n plus 24. Then minus away f0, replacing all the r by 0, it is just simply a 24 here. Okay, this is 1 over 6. And what I have left with is 2n cubed plus 3n squared plus n. Okay, what we can do is, let's try to factorize this. Well, I'm going to factorize out n. So this is 1 over 6n of 2n squared plus 3n plus 1. Okay, which I can factorize further. Factorizing this further, it is 1 over 6n of this is going to be n plus 1, okay, and 2n plus 1. Okay, and this is the result of summation of r equal to, from r equal to 1 to n of r squared. And if you can recall, in our outline, we do have this in our standard result. Okay, because our standard result of r squared, it is one of the two summation that I was saying. Okay, please try to memorize it. And now what we have done is we have proven that standard result.